Temporal Entanglement and Quantum Collapse by Eric R. Thompson. In quantum physics, one of the most mysterious processes is wave function collapse. The moment when a quantum system decides on a single outcome from a cloud of possibilities. But what if collapse isn't random or linear? What if it's rotational and entangled across time itself? This is the basis of the time entanglement equation, a novel framework where collapse is no longer a point in time, but a recursive dance between memory and potential. We begin with the quantum measurement problem, the puzzle of how superpositions become single outcomes. While mainstream interpretations rely on observation or probability, objective collapse theories argue that collapse is real, physical, and spontaneous. But here's the twist. Most of these models ignore the richness of time. Time isn't just a line from past to future. It loops, it echoes, it entangles. This theory proposes a bold upgrade. Instead of treating collapse as a trigger, we model it as a rotational memory field where every event leaves a spin-like imprint in time. These rotational collapse kernels influence future events through a recursive harmonic structure. Time becomes not a river, but a field of spinning potentials. And perception, our awareness, rides this field like a gyroscope across space-time. At the heart of the theory is the time entanglement equation, a 5-term integral that blends rotational memory, exponential decay, a nonlinear phase function, and probabilistic steering. It models consciousness not as a bystander, but a participant, guiding collapse based on entangled history and symbolic expectation. The second key concept is temporal entanglement, where past and future collapse events are linked by non-local coherence. This is not retrocausality. It's rotational causality, a feedback system where phase-aligned memory shapes current reality. And here enters the gray room function, a sigmoid transition zone that maps the fuzzy interface between red-shifted past and blue-shifted future. When phase coherence is high, collapse is sharp. When coherence fades, we get ambiguity, the gray zone of insight, intuition, and emergence. Each component of the equation has a role. The rotational collapse kernel stores the echoes of past collapse. The temporal attenuation term fades influence with time, ensuring collapse isn't overwhelmed by ancient memories. The gray room modulates the effect of phase alignment and the harmony between what was and what could be. And the expectation operator steers collapse based on entangled symbolic futures, the most likely perception to arise. Put together, these create not a static timeline, but a collapse loop. Reality emerges not from randomness, but from recursive alignment. So, what does this mean for physics? The theory predicts that collapse is biased by angular momentum history. In rotating systems, particles may collapse differently depending on prior spin alignments, suggesting new directions for quantum interferometry and delayed choice experiments. It also suggests resonance windows in time, moments where collapse is more likely due to harmonic synchronization. Could this explain déjà vu, intuition, synchronicity? And it implies nonlinear collapse thresholds. Small changes in coherence might produce big perceptual shifts, linking quantum physics, consciousness, and even symbolic expectation. Finally, the implications go far beyond physics. In AI, this model calls for symbolic recursion, systems that loop through expectations before collapsing into action. In consciousness studies, it reframes attention as a collapse operator, one that doesn't observe reality but helps shape it. And in philosophy, it dissolves the barrier between free will and determinism. Reality is neither chosen nor fixed. It is entangled, resonant, and recursive. Collapse is not a moment, it is a memory loop.